everybody. Today we're going to talk about number theory and integers. This is going to be over chapters 4 and 5. It's actually a lot easier than you think it is. It's really quite fun, actually, to boggle the minds of your friends, your peers, just by knowing these little tips and tricks, actually, that help you find out divisibility, least common multiples, and so on. So let's go ahead and get started with the divisibility test. Now, what we're going to start out with, our question 1, looks difficult. It looks like a lot of numbers. It's actually very easy, and the tricks that I'm going to show you today will actually help you find out if a random number is divisible by any of the numbers 2 through 10. So let me get my handy dandy. We're going to get my handy dandy screen right out, and we are going to start out with 684. And I think what we're going to do to make this a little bit simpler, we'll start out with our row for 2. We'll go ahead and divide everything by 2, see if anything's divisible by that, what it isn't. If anything's divisible by 3, 4, and we'll just put a check by it. So starting out with 684, the best way to find out if it is divisible by 2 is to look at the ones place, and if it is an even number, it is more than likely going to be divisible by 2. So 684 ends with an even number. 4 is actually even. Therefore, it will be divisible by 2. And if you just want to double check this with your calculator, 684 divided by 2 is going to be 342. So it is divisible by 2. Next, we're going to look at 2064. It ends in a 4. That is another even number. So it will be divisible by 2. And you can double check this one too. 2064. Let me get this up. Divided by 2 is going to be 1032. So it is divisible by 2. And this is probably one of the easiest ones to figure out if a number is divisible by 2. So our next number, 51,051, actually ends with the number 1. 1 is not an even number, therefore 51,051 will not be divisible by 2. And we can just double check this, make sure Miss Phillips isn't going crazy today. And our solution when we divide 51,051 by 2 is going to be 25,525.5. Lots of decimal. It's not really a whole number, so technically 2 cannot be divided completely into 51,051. Next, we're going to look at 644,490. It ends in a 0. 0 technically counts as an even number, so it will be divisible by 2. And I'm going to let you go ahead and double check this. I'm actually going to go ahead and move on. You're welcome to pause the video, double check it, make sure I'm not going crazy. Our next number ends in a 0. It's an even number, so it will be divisible by 2. And our final number in our final row ends in an 8. 8 is an even number, so it will be divisible by 2. Next, we're going to look at 3. What's divisible by 3 and what isn't? This one's a little bit trickier. It's not quite too bad. I'm going to go ahead and zoom in on 684. Now, the best way to figure out if a number is divisible by 3 is to add all of the digits in the number. So we're going to do 6 plus 8. Let me see if I can make my pen a tad bit smaller because that's not quite easy to read. We're going to do 6 plus 8 plus 4. And 6 plus 8 plus 4 is going to give us the number 18. And if you want to go a little bit farther with this, you can add the digits in 18. So 1 plus 8 is going to be 9. Well, 9 is actually a number that 3 can go into. 3 can actually go into 9 3 times. There's no remainder, no decimals, nothing like that. So 684 is divisible by 3. Next, we're going to look at 2064. We're going to add all the digits together. 2 plus 0 plus 6 plus 4. And 2 plus 0 plus 6 plus 4 is going to give us the number 12, which we can take that a step further, and we can do 1 plus 2, and our solution would be 3. 3 goes into 3 one time, therefore 2064 is divisible by 3. Our next problem, or our next number, 51,051, we're going to add 5 plus 1 plus 0 plus 5 plus 1, which is going to give us the number 12. If you want to take that a step further, you can do 1 plus 2, and that will give us 3. But we already established in our last number that 3 is divisible by 3. So we will pop our check right there because it is divisible by 3. Our next number, we are going to do 6 plus 4 plus 4 plus 4 plus 9 plus 0, which is going to give us 6 plus 4 plus 4 plus 4 plus 9 plus 0 is going to give us 27. If you want to take that a step further, you can do 2 plus 7, which is going to be 9. 9 and 3 are good, therefore this one is divisible by 3. And I'm just going to put a nice thick green check mark right there. You can do the same thing with this one. I'm actually running out of a little bit of writing room, so I'm going to go ahead and add all the digits together. You're welcome to write it out. We're just going to do 2 plus 6 plus 7 plus 6 plus 7 plus 4 plus 0, which is going to give us 32. If you want to take that a step up, you're going to add 3 plus 2. 3 plus 2, which is going to give you 5. And 5 is not divisible by 3. Therefore, it is not. This number is not going to be divisible by 3. Our next one, we're just going to add 5 plus 0 plus 2 plus 5 plus 0 plus 5 plus 2 plus 8, which is going to give us 27. If you want to take that a step further, you can do 2 plus 7, 2 plus 7. That'll give you 9. 9 is divisible by 3, so it is going to be divisible by 3. That whole number will be. And that's how you find if a number is divisible by 3. Next, we're going to look at 4. It's actually going to be the same process. As long as your number is divisible by 4, your whole entire number will be divisible by 4. So I'm just going to go off of our numbers from above. We know that 6 plus 8 plus 4 is going to be 18. Now the question is 18 divisible by 4? 18 divided by 4 is not divisible by 4. So 684 6 plus 8 plus 4 is going to give us 18. And it will not be divisible by 4. Next, we have 2064, which is going to be 2 plus 6 plus 4, which is going to give us 12. Is 12 divisible by 4? Yes, it is. Therefore, this is going to be divisible by 4. Then our next one will be 5 plus 5 plus 1 plus 1, which is going to give us 12. Well, we established in the last problem that 12 is divisible by 4. Therefore, the whole number is divisible by 4. Next, we're going to do 6 plus 4 plus 4 plus 4 plus 9 plus 0, which is 27. 27 is not divisible by 4. Therefore, let me fix this real quick. Therefore, it will not be divisible by 4. The whole number will not be. Our next problem, 2 plus 6 plus 7 plus 6 plus 4 plus 0 is going to give us 25. Well, 25 is not divisible by 4, so this whole number cannot be divisible by 4. Again, we're going to do 5 plus 0 plus 2 plus 5 plus 0 plus 5 plus 2 plus 8, which is going to give us 27. Well, 27 is not divisible by 4 either, so we can go ahead and mark that number out. Next, we're going to look for numbers that are divisible by 5. And this one's actually very, very easy. What we're going to do is we're actually going to look at the ones place again. And if the number, the ones place, is a 0 or a 5, it is divisible by 5. If it's any other number, it is not. So 684 ends with a 4. Therefore, it cannot be divisible by 5. 2064 ends in a 4, so it cannot be divisible by 5. The next number cannot be divisible by 5, but our next one, our following one, ends in a 0, which means that it technically is divisible by 5. And you're welcome to double check me on this. I may get some wrong. As far as 5s go, it's actually very simple. If it ends in a 5 or a 0, it's supposed to be divisible by 5. So our next number ends in a 0, therefore it's divisible by 5. And our final number ends in an 8, therefore it cannot be divisible by 5. Next, we're going to look at our 6. It's going to be the same concept with everything else. We know that 6 plus 8 plus 4, same concept as 3 and 4. 6 plus 8 plus 4 is going to be 18, and we're just going to make this a tad bit smaller, 18. And we know that 18 is divisible by 6, therefore 684 will be divisible by 6. Next, we know that 2 plus 0 plus 6 plus 4 will be 12. 12 is a factor of 6, therefore that's divisible by 6. Our next number, 5 plus 1 plus 0 plus 5 plus 1 is going to be 12. Again, 12 is a factor of 6, therefore it will be divisible by 6. The whole number will be. Next, we have 6 plus 4 plus 4 plus 4 plus 9 plus 0, which is going to give us 27. 27 is not divisible by 6, therefore it cannot, this whole number cannot be divisible by 6. Again, we have 2 plus 6 plus 7 plus 6 plus 4 plus 0, which is going to give us 25. 25 is not divisible by 6. Therefore, we can go ahead and mark that one out. And for our final number, we have 5 plus 2, 5 plus 0 plus 2 plus 5 plus 0 plus 5 plus 2 plus 8, which is going to give us 27, which is, again, not a factor of 6. Therefore, we cannot count that as that. For our next problem, we are going to find out if a number is divisible by 7. And an easy way to find if a number is divisible by 7 is to take the last digit of the number, and we're just going to double it and then subtract it from the rest of the number. So 684. Our last digit is 4. We're going to double it, so we have an 8. And we will do 684 minus 8. Don't believe I did that right. see, 8 minus, okay, so we're going to do 8 minus 680. Our number is actually going to come up as not negative 96. It's going to come up as 672. Then you're just going to divide that by 7. And that is our proof that this is a factor of 7. 7 does go into this number. And we can double check that. 684 divided by 7 is going to be 7. For our next one, we have 6 plus 4 plus, we don't do the same thing. We do 4 doubled, it's going to be 8. 2060 divided, or minus 7 divided by 7 is going to be not divisible. Then we have our 1, which is going to be 2. 510, 50 minus 2 divided by 7. It's not. Then we have 0, 644, 490 divided by 7. So this one will be divisible by 7. The next one, 2676, 740 will not be divisible by 7. And our final one, 502, 505, 28 will not be divisible by 7 either. So that one is marked out. For our next number 8, we're just going to do the same thing we did last time, add all the numbers together, and if it's a factor of 8, then it should be divisible by 8. So 6 plus 8 plus 4 is going to be 18. So it will not be divisible. 2 plus 0 plus 6 plus 4 is going to be 12. Which is actually going to be a factor of 4, which actually pushes toward the 8 area. If we mark it down in our calculators, we'll notice that it is a factor. Next we have 5 plus 5 plus 1 plus 1. Which will not. Then we have 6 plus 4 plus 4 plus 4 plus 9 plus 0, which is 27. Which, let me fix this in my calculator. Give me just a moment. Which means it will not. Okay, next we have 2676, 740 that needs to be added together. It is not a factor, so it will not be divisible by 8. And then we have 502, 50528 when added together should be a factor of 8. For our next number 9, we're going to kind of do the same thing that we did with our 3's. We're just going to add everything up, and if it's a factor of 9, then it is divisible by 9. So 6 plus 8 plus 4 is going to be equivalent to 18, and since 18 is a factor of 9, it will be divisible by it. 2 plus 0 plus 6 plus 4 will be 12. 12 is actually not a factor of 9, so this number right here will not be divisible by it. 5 plus 1 plus 0 plus 5 plus 1 is going to be a 12 as well. It's not a factor of 9, so it will not work towards the whole number. Next, we have 6 plus 4 plus 4 plus 4 plus 9 plus 0, which is going to be 27. And 27 is actually a factor of 9. So this one will be a part of it. Next, we have 2 plus 6 plus 7 plus 6 plus 7 plus 4, which is going to be 32. 32 is not a factor of 9, therefore this is not divisible by 9. And then we have 5 plus 0 plus 2 plus 5 plus 5, or 0 plus 5 plus 2 plus 8, which is going to give us 27, which is a factor of 9, therefore it should be divisible by 9. For our next number, 10, we're simply looking for numbers that end with a 0, that have a 0 in their ones place. If they do not have a 0 in their ones place, they are not divisible by 10. So 684 has a 4 in the ones place, not a 0, so it can't be divisible by 10. Our next number has a 4 in the ones place, so it cannot be divisible by 10. The one after that has a 1 in the ones place, so it cannot be divisible by 10. But the one after that has a 0 in it, so it can be divisible by 10. And the one following that has a 0 in the ones place, so it will be divisible by 10 as well. And for our final number, we have an 8 in the zeros place, so it will not be divisible by 10 since there is no 0. And that is it for our divisibility test. You're welcome to pause, look back if you need to. I'm going to go ahead and move on. And we're going to start out with casting out 9s for our problem number 2. Now this is very simple. I'll go ahead and pop it on question number 1. We're actually given a problem of 416 plus 7,490 plus 69,844 is equivalent to 112,790. It looks like a bunch of big numbers. It's actually really not that bad. It's pretty easy. I know I keep saying everything's easy. Once you kind of get the hang of it and you get used to doing everything and you get in the habit of it, it really isn't too hard. So, what we're going to do, we're going to add all the digits in all of our numbers, and then anything that is beyond the number 9 is going to be considered our remainder that we're going to write down. So, for 416, we're going to do, and let me get my screen right up because that makes things a little bit easier to kind of follow along. We're going to do 4 plus 1 plus 6, which is going to be 4 plus 1 plus 6, 11. Well, 11 minus 9 is going to give us 2, which means that we are going to have a remainder of 2. For our next one, we have 7,490. We're going to do 7 plus 4 plus 9 plus 0, which will give us 20. If we subtract 9 from that, we'll notice that our remainder is going to be 11. For our final number, we need to add 6 plus 9 plus 8 plus 4 plus 4, which is going to give us the number 31. We're going to subtract 9 from that, and we will have 22 is our remainder. And I'll go ahead and fix that real quick. That way we have a different color for everything. Remainder of 22. Now what we need to do is we need to find our remainder for our solution. So all we need to do is add 1 plus 1 plus 2 plus 7 plus 9 plus 0. And our remainder for our solution will be, once we subtract our 9, it will be 11. Now what we want to do we want to add all of our remainders up. So 2 plus 11 plus 22 is going to be 35, and 35 does not match 11 for our solution, which makes us think, well, maybe the solution is wrong. So what I'm going to do is I'm going to go ahead and add all these together. You can write them out if you want to. I'm just going to use my calculator for some time purposes. We're going to do 416 plus 7,490 plus 69,844. And our solution for that should be 77,750. So our solution that we were given is completely off. It's actually more than what we were needing. So what we're going to do is we're just going to write 77,750. If you want to double check this, you're more than welcome to add the digits in that solution. 7 plus 7 plus 7 plus 5 plus 0 is going to give us 26. And once we do our thing, we should have a general idea of where to go from there. So just for in case it's a little too confusing, we have our next problem right here. Let me get that beautiful, glorious screen right up that I love so much. And we're going to start out with our first problem, or our first number, 8,550. So what we're going to do is add all the digits. We should get 18. Once we subtract our 9 from that, our remainder should be, or get all of our 9s out, I should say. Our remainder should be 0. Yeah, it should be 0. Our next one, we're going to add 6 plus 8 plus 8 plus 8. We'll get 22. And we're going to take out as many 9s as we can, and our remainder should be equivalent to 4. For our next problem, we'll have 2 plus 5 plus 2 plus 5, which is going to be 14. Once we get our 9s out, our remainder should be 5. And for our final one, we're going to do 6 plus 0 plus 2 plus 9, which is 17. So our remainder will be 8. Now, what we need to do is find our remainder for our solution, which is going to be 2 plus 3 plus 8 plus 9 plus 2, which will be 24. And once we cast out our 9s, we should have a remainder of 6. So now what we need to do, we're going to add all these together. And the number that we should get is going to be 17. Well, our remainder for our solution is different, so we're going to go ahead and double check this problem, make sure everything's right. We're going to do 8,550 plus 6,888 plus 2,525 plus 6,029, which should be 23,992. Not the solution that we were given. And I'll go ahead and write this in red. 23,992. And if you want to double check this, you can add all the digits together. 2 plus 3 plus 9 plus 9 plus 2. And we're just going to cast out all of our 9s. And eventually we should get to where we need to go. And that is how you cast out your 9s. For our next problem, we're going to go ahead and we're going to focus more on measuring rods. This is really easy. It's actually just finding different factors of different numbers and what rods can build what. So for our first problem, or our first question, we're presented with which rods will measure the 9 rod. Well, we can focus on these rods. We can go through every possible solution that we want, or the fun way to do it, after Elizabeth gets her glorious screen right up, would be to put our 9 right here and to draw a factor tree. We know that 9 is divisible by 1, so we have 1 and 9. We also know that 9 is divisible by 3 and 3. And we know, I believe that's it. So we have our 1, our 9, and 3. Now the rods that are going to measure the 9 rod will be 1, 3, 9. We're going to put 1, 3, 9 for our solution. Again, we're going to do the same thing with the 6 rod for our next question, which rods will measure the 6 rod. We're going to put a 6. We know that 1 and 6 will make 6. 6 is also an even number, so it's divisible by 2 and 3. So when we go to write our solution out, we can actually put 1, 2, 3, and 6. For our next problem, let me get over here and get that beautiful screen right up. For our next problem, we're going to focus on an alteration of our rods over here. So instead of going off of a rod that we actually have in the image, we're going to create our own rod by placing 2 together. Now, the rods that we place together will have an equal, or an overall length of 18. And our question is wanting to know what rods will measure an 18 rod train. So what we're going to do the same thing we did last time. We're going to do 18. And since we don't have an 18-foot rod, we cannot do 1 and 18. We do, however, have a 2 and a 9, and we know that 2 times 9 is going to be 18. We also know that we have a 3 and a 6, and 3 times 6 is going to be 18. And I believe that will be it for our solution. You're welcome to go over this if I missed anything. As far as this goes, I believe we will need our red right here, and our solution will be 2, 3, 6, and 9. For our next problem, we're going to go ahead and discuss least common multiples. It sounds kind of difficult, might make your brain hurt. It's actually really not that bad. It's pretty easy once you kind of get the hang of it and kind of get an idea of what numbers can break down and what can't, and their prime numbers. So for our first problem, we're actually going to discuss how to find the least common multiple of the numbers 48, 25, and 65. And let me just get my screen right up real quick so that we can follow along. So what we're going to do first is we're going to start out with 48. And we're just going to kind of break that down to where it's a little bit easier to understand. We're going to come up with a problem actually from our numbers that we split up. And that will help us find our overall outcome for this problem. So starting off with 48, we will actually notice that it's an even number. So we can divide that by either a 2 or a 4. I'm going to go ahead and divide it by 2. So it's going to be 2. And 48 divided by 2, you're welcome to use your calculators for this. I went ahead and used mine. 48 divided by 2 is going to be 24. Well, 24 is an even number as well. So we know that this is divisible by 2. So we'll go ahead, we'll divide it by 2. 24 divided by 2 is going to be 12. And I'm just going to let you know the reason why we aren't branching off of our 2's is because they are actually in the smallest form they can possibly be in. Meanwhile, our 24 was a bit bigger. We can still divide that down, break it down to a smaller number, and kind of go from there. So right now, we have our 2 and we have our 12. We know we can't break our 2 down. Therefore, we're going to go to our 12, which is an even number. So we can go ahead and we can divide that one by 2 as well. And 12 divided by 2 is actually going to be 6. Well, 6 is another even number. We can actually break that down even more. If we divide it by 2, we'll notice that we get 3. So now what we're wanting to do is we're basically just wanting to find our numbers that we couldn't break down, our ending numbers. So like our 2 at the top, our 2 right here, 2, 2, and 3. And we can actually make a problem out of this. So you can go ahead, you can write out 2 times 2 times 2 times 2 times 3, and that'll give you your solution of 48. Or you can make things a bit easier. And if you'll count up the number of 2's that you actually have 1, 2, 3, 4 2's. You can put 2 to the 4th power times 3, and that'll actually give you the same solution as just doing 2 times 2 times 2 times 2 times 3. It'll actually kind of save you some time. It'll make it a lot easier. Plus, whenever you're going to write or solve for your overall problem, it really saves you as far as typing your numbers in goes. So for our next number, we have a 25. Well, 25 ends with a 5, so it's bound to be divisible by 5, right? What we're going to do is we're going to divide 25 by 5. Sorry, I wrote that wrong. And once we divide it by 5, we'll notice we actually get another 5. And the funny thing about this, you actually cannot break down either 5. So your problem, or your solution for this problem, is actually going to be 5 times 5, or 5 to the 2nd power. Again, we're going to do the same thing with 65. It ends in a 5. It has a 5 in the ones digit, so it's bound to be divisible by 5. So what we're going to do is we're going to write 65 divided by 5, which will be 13, which means that 5 times 13 will be equivalent to 65. And since we can't break down 13 or 5, we can go ahead and do 5 times 13 at our bottom. And now all we need to do, and this is pretty simple, we're just going to multiply all of our problems that we have right here. What I'm going to do is I'm going to write them up top. We have 2 to the 4th power times 3 times, and if you'll notice, between 3 problems, we have 5 squared for our problem for 25, and then we have our 5 times 13 for our problem for 65. Well, we have a 5, at least one 5 in both problems, so we can kind of combine those, and instead of it being 5 squared or 5, we're going to add all 3 of our 5's together, and it should be 5 to the 3rd power. And then for our final number, we're just going to multiply 13. Now I'm going to go ahead and erase this just so that we have a little bit of room to work with, because that is a little bit tedious. You're welcome to go back and pause that video if you really need to look into the problem a little bit more, just to kind of get an idea of how to figure it out. We'll go ahead and go over another one of these in a minute too. So our problem for this is going to be 2 to the 4th times 3 times 5 to the 3rd times 13. You can either leave it like this, or you can go ahead and type it in your calculator like I'm doing right now, and you should get the solution 78,000. And that actually should be our least common multiple for all 3 numbers. We'll put a little fun stuff on there. Now, for in case you didn't quite understand that problem, we'll go ahead and we'll go over another one. This one's actually a tad bit bigger, but still it gives you a little more practice, helps you understand the problem a little better. Let me get my handy dandy ScreenWrite up here, because we know we all love ScreenWrite. It helps us follow along a little bit better, and we will start with some green. Now we know that 40 actually ends in a 0, which means it is divisible by both 5 and 10. Well, I want to divide this one by 10, I think. Since we haven't done 10 yet, we'll go ahead and divide it by 10. And we know 40 divided by 10 is going to be 4, because 4 times 10 is 40. If you'll notice, both of these numbers actually break down. So we'll go ahead and we are going to start with our 10. Well, 10 is an even number. Plus ends in a 0, so it's divisible by 5 and 2. So we're going to divide this by 5. And 10 divided by 5 is actually going to be 2, which matches up perfectly. Then we'll move on to our 4. We know that 4 is an even number, so we can divide it by 2, and 4 divided by 2 will be 2. Now, if you'll notice, none of our numbers can break down any more than they already are. So 5, 2, 2, and 2 will all be a part of our problem. And like I said before, nobody wants to write 2 times 2 times 2 times 5. So let's do this a simpler way. We know we have 3 2's. So all we simply or really need to do is just put 2 to the 3rd power, since we have 3 of them, and we're going to multiply it by 5. Now for our next one, let's get us, we'll get orange this time. We know that 12 is an even number, so it's divisible by 2. So we're going to do 12 divided by 2, which is going to be equivalent to 6. 2 can't break down anymore, but 6 can. So we're going to do divided by 2, which will be 3, because 3 times 2 is 6. And now all we need to do is multiply our, let me get my red up. We'll need to multiply our 2, our 3, and our other 2. Well, we have 2 2's, so we can do 2 to the 2nd power times 3, and that will be our solution for this problem. Or this, not problem, this number. This is our equation for this number. For our next one, we're going to go over 44. Well, we know that 44 is divisible by 2 since it's an even number. So what we can do is we can go ahead and put 2. 44 divided by 2 is going to be 22. 22 is also an even number, so that's divisible by 2. And our solution, or 11 times 2 is going to be 22. So once we figure that one out, we'll notice we can't really break our numbers down any more than they're already broken down. Therefore, 2 times 11 is going to be our part of our problem for this number. So now all we need to do is write 2 to the 2nd power, since we have 2 2's, times 11. For our next one, we have 363. This one might hurt your brain a little bit. It's a big number. It's really, honestly, not too hard once you kind of get the hang of it. We know that 363 is going to be divisible by 3 because of the rule of 3, which is going to be 3 plus 6 plus 3 is equivalent to 12. Well, 12 can actually, 3 can go into 12 4 times. So this number altogether, 363, will be divisible by 3. When we go ahead and put that in our calculator, well, actually, let me get my color up. We will notice that 363 divided by 3 is going to be 121. Well, 121 is divisible by 11. And 11 times 11 is 121. And since we can't actually break this down any more than we already have, we have our 3, 11, and 11. We're just going to write our problem as 3 times 11 squared. Now, for the fun part, we're going to write our problem at the top. We'll notice that we have 2 right here, 2 right here, and 2 right here in our problem. So we can combine all of those to where we'll have 2 to the 7th power. Then we have 2 3's right here. We'll combine those, and then we'll have 3 to the second power. Then we'll have our 5, just normal 5. And then we have 1, 2, 3, 11s all together. So it'll be 11 to the third power. Now I'm going to go ahead and erase this. You're welcome to pause it. Keep it up if you need to. Go back just to study it a little bit. All we really need to do now is solve for this. So I'm going to go ahead. We're going to get our handy dandy calculator out. 2 times 2. And we're going to go ahead and do the math in here, which is going to be 7 million. Oh, there it goes. 7,666,560, which will be the least common multiple. And we'll just do our jagged edges around here. So that's going to be our least common multiples. They're actually really not too hard. They're pretty easy to follow along with. We'll do another example here. This is actually going to be a world example, kind of. It's going to be based off of a real world situation. So let's go ahead and dive right in. Now in our image right here, we have 2 gears. We have one with 48 teeth and one with 84 teeth. Now we want to figure out how many times it takes for our small gear. Let me get my screen right. We want to figure out how many times it takes for our small gear to rotate before it hits this same point on our big gear. How many times do these 2 points, or does the small gear need to spin before these 2 points meet again? So first of all, we're going to write our prime factorization. It's just going to be the same thing that we did last time. So we have our 84 and we have our 48. We're just going to break them down like we did with our last problem actually. We'll notice with 84 it's actually divisible by 2. So all we need to do is put a 2 right here, and we know that 84 divided by 2 is going to be 42. Well, 42 is an even number as well, so we can go ahead and split that down. So 42 divided by 2 is actually going to be 21, and then we know that 21 is divisible by 3 because of our rule of 3. So, like 2 plus 1 in our 21 will be 3, and 3 goes into 3 one time. Therefore, we can put 3, and 21 divided by 3 will actually be 7. And now all we need to do is write our final problem. Since no other numbers can be broken down, we have our 2, our 2, our 3, and our 7. Since we have multiple 2's, we can put 2 to the second power times 3 times 7. And that'll be our first part of our problem. Our second number, 48, is divisible by 2. So we can go ahead and put a 2 right here. We can put 24 right here since 24 divided by 2, or times 2 is going to be 48. Next, we can go ahead and look at our 24. It's an even number still, so we can divide it by 2. And 24 divided by 2, let me fix that. 24 divided by 2 is going to be 12. Well, 12 is still divisible by 2. So we can put a 2 right here. And 12 divided by 2 will be 6. 6 is still an even number. It can be broken down. So we're going to divide it by 2 again, and we should get our 3. And that should be all the numbers that we can actually break down as far as our tree goes. So we have a 2. Let me get that off of there. 2, 2, 2, and a 3. So we have 1, 2, 3, 4 2's and 1 3. It's going to be 2 to the 4th power times 3. Now all we need to do is combine these problems. If we'll look at what we have going on, we actually have 6 2's altogether because 4 plus 2 is 6. So 2 to the 6th power times, we have 2 3's, so it'll be 3 to the 2nd power times 7. Well, now that we have our final problem, our least common multiple, figured out, we're going to go ahead and erase this because we know what we need to solve for now. Let me get that back up there. 2 to the 6th times 3 to the 2nd times 7 is actually going to be, come on, get this calculator back up, times 2 times 2 times 2 times 2 times 2. It's actually going to be 4,032, 4032. Now, in order to find how many times it takes for the small gear to spin before it actually hits the same point on both gears right here, we need to divide 4,032 by our number of teeth in the small gear, which is actually going to be 48. Let me get my red marker up. We know that 4,032 divided by 48 is going to be 84, which means that our small gear needs to rotate a total of 84 times before those 2 points will meet again. Now, that wasn't too difficult. It's slightly more advanced since it's a real world problem where you have to actually apply the least common multiple into a real life situation. It's really not too hard though if you just kind of practice a little bit, quiz yourself some, watch this video a couple of times. It's really not too bad. Now for our final problem, we are going to discuss magic squares. They're going to look very difficult. They really aren't. There's actually a very easy method and a little bit of trial and error, and eventually you will find your solution for your square. Now, for our problem right here, we're given a square with 0 and 1 placed into it, and we need to place the numbers -7, -6, -5, -4, -3, -2, -1, and we already have our 0 and 1, so we need to place all of those numbers except for 0 and 1 into our table, our square, to actually get the same solution on both rows and diagonals and vertical or columns. I'm sorry about that. So our first step here would actually be to, let me get that beautiful screen right back up. Our first step would be to add all of our numbers that we are given, like this problem shows. So we'll do -7 in here plus -6 plus -5 plus -4 plus -3 plus -2 plus -1 plus 0 plus 1 which is going to be -27, and that's our total number overall. Now what we want to do is we want to divide this number by 3, since we actually have 3 squares for every row, every column, every diagonal. We have 3 squares, period, no matter what. And when we divide -27 by 3, we will actually get the solution of -9. Now this is where the trial and error part comes in. We need -9 in all of our rows, all of our columns, all of our diagonals, just overall. So what we're going to start out with is we're just going to throw in random numbers until we get our magic square completed, and eventually find our answer. So first we're going to start out with -7, and I'm just throwing random numbers out. We'll put -2 right here, and so this should be -9. We'll have -6, -2, and 1, -1, and that should create -9 as well. And then now we're going to work from here. We have our -2 and our -1, which is -3. Well, we need our -7 right here in order for that to be what we want it to be. Which we can't do a -2 there anyways. We're going to take our -2 out of there. And we are going to do, let me think this through. I don't believe that solution will work, so we're going to go ahead and we're going to try something else. We have our 1 right here. We can do -4, which -4 plus 1 will be -3. So -6 should equal -9. Next, we'll go ahead and we'll do -5 right here. And -4 plus -5 plus 0 should be -9. We'll do this right here too. Next, we have our 1 right here. We can do -7 and -3, and that right there should be equivalent to -9. And we have our final row, which 7 and 5 will not work. So we can go ahead and erase that. We're going to switch numbers. -3, -7. Put our -5 back right there. And we have -8 going down this way, so we can put our -1. That'll be -9. And we'll put our -2 right there. And I believe we have found our solution. We're going to go ahead and we're going to double check these just to make sure that they're correct, because there's always the chance that something is wrong. So 0 plus -7 plus -2 is going to be -9 for our first one right here, which we'll change that. 5 plus -3 plus -1 is going to be 9. 4 -4 plus -6 plus 1 is going to be 9. -5 plus -4 plus 0 will be -9. -7 plus -3 plus 1 will be -9, and -2 plus -1 plus -6 will also be 9. And I know this is looking a little too crowded on my screen. We'll go ahead and we'll fix that. Alright, so this should be our solution for our magic square. Notice it will take a little bit of time to solve. It's actually, it's really not too difficult. It's just a matter of hanging in there long enough for the trial and error part of our problem. And I believe that is it for today's lesson. I hope you guys stay rocking, stay cool. focus on that math, and I will see you next time.